Scientists have been looking to find traces of life in the universe, and one of the best guesses they have so far is that life can potentially exist on an exoplanet that is close to its host star and which just has the right temperature for liquid water to exist, because we all know life requires water. But so far, scientists have not been able to find an exoplanet with just the right ingredients to harbor life. But they do have the James Webb Telescope that has the potential to find the unexpected, as it has already set on a mission to groundbreaking discoveries. If you don't already know this, the James Webb Telescope has recently discovered its first exoplanet, and chances are it can support life. If you don't know about this groundbreaking discovery by the Space Observatory, it is highly recommended you check out the video we made about the discovery of the exoplanet that will let you in on all the essentials of the new finding. Recently, NASA has reported the discovery of a rocky exoplanet, roughly the size of Earth, that could most likely support life. The discovery was made by TESS, the Transiting Exoplanet Survey Satellite, a NASA mission to discover Earth-sized worlds around nearby stars. As of 2021, more than 4,500 planets orbiting other stars in our galaxy have been discovered. Kepler, NASA's first planet-hunting space observatory, discovered over half of these exoplanets shortly after it was launched in 2009. Even though most of the planets Kepler discovered were much bigger and more massive than Earth, the project showed if we could launch a dedicated mission, our search for life could be refined. The Transiting Exoplanet Survey Satellite TESS was launched in 2018 as a follow-up mission by NASA, MIT, and other institutions. Unlike Kepler, TESS is specifically designed to find Earth-sized planets orbiting some of the nearest and brightest stars, so that they can be examined by future telescopes. TESS's force-sensitive cameras imaged 75% of the sky over the duration of its 2-year primary mission, cataloging more than 200,000 of the nearest and brightest stars. It uncovered 2,100 potential planets and 66 confirmed exoplanets. While TESS data tell us the size and orbits of these planets, ground telescopes can tell us their masses. When these three factors are known, it may be determined if the planet is likely to be rocky like Earth, gaseous like Jupiter and Saturn, or something else entirely. Many of the planets identified by TESS are the target of JWST, allowing researchers to examine the atmospheres of exoplanets in considerable detail. By the way, do you guys think that life can exist on exoplanets? Like this video if you do. Recently, TESS came across the planet named TOI 700e, which is slightly smaller than Earth and orbits a red dwarf star called TOI 700, about 100 light-years away. It's one of 4 planets to orbit the star, alongside TOI 700b, C, and D. It was already known that TOI 700d was in the habitable zone, thanks to NASA's Transiting Exoplanet Survey Satellite, which watches vast stretches of the sky for 27 days at a time to track variations in stellar brightness caused by planets. It took researchers over a year to find TOI 700e and determine that it was in the star's habitable zone, but the wait was well worth it. An article detailing its discovery was accepted for publication in the Astrophysical Journal Letters, after being presented at the Seattle American Astronomical Society meeting. For those who don't know, the habitable zone or Goldilocks zone is the optimum distance from a star where liquid water could exist on an orbiting planet. It gets its nickname because the conditions on the planet are not too cold or too hot to sustain life. Both TOI 700e and D, as determined by scientists, lie within the optimistic habitable zone, suggesting the presence of liquid water on the planets at some point in their pasts. If you want to know more about the planets that can support life, then don't forget to check the video that we made and thank us later. So TOI 700e is about 95% the size of Earth and is probably a rocky planet similar to ours. It is about 10% smaller than planet D. It is the 4th planet found in the TOI 700 system. However, it is located in the middle of planets C and D. TOI 700e takes around 28 days to complete an orbit around its star, and it's possible that the planet is tidally locked, meaning that it only spins once per orbit and that the same side is always facing the star. It's like how the moon always has the same face toward Earth. TOI 700e is one of the many habitable zones that can sustain life. An old joke offers an answer. Asked why, on a dark night, he was looking for his missing car keys beneath a street lamp, the man answered, because the light's better. It's possible that extraterrestrial life is completely different from anything we have ever seen on Earth. However, it makes sense to look for something familiar at first. life as we know it should be easier to find, and the light's better in the habitable zone, or the area around a star where the planetary surface temperatures could allow the pooling of water. When looking for life, similarities to Earth just kind of get the attention and get the hopes up. There are a lot of rocky planets in Earth's size range that have been discovered, which is good news for the possibility of life. In light of what we have seen in our solar system, gas giants like Jupiter are unlikely to sustain life. So looking for exoplanets that look like ours even in the slightest way can mean we can expect to find some form of life there. TOI 700e is one of the many possible places scientists have been looking for habitable conditions. There are still many undetected exoplanets that mimic Earth but are yet to be discovered. We just have to wait and watch and let the future unfold. And who knows what we're going to find out. James Webb is an important instrument in detecting the atmospheres of the exoplanets, but do you know how James Webb intends to do that? Watch this video before it's too late and find all the answers about what plans scientists have for James Webb and how it is going to evolutionize the research. See you guys tomorrow at 9 p.m. Central Europe time. Until then, stay tuned.